Hey everybody, Lars here. Tonight we're going to do the last of the review videos for Unit 3. And what we're going to talk about tonight is a topic that I call modularity. And basically what we're going to do is we're going to review very quickly the math library and the standard library and discuss import and use some of the functions that are written for us already and they're sitting in the standard library. And then after that, we're going to create our own library and we're going to import a module that we create, and hopefully you will learn a great deal about what to do for assignment number 2, because I'm going to read from a data file and then we're going to use a function that resides in a library, and a lot of it is similar in process to what we're going to do for assignment number 2. So let's get underway. I already set up a file for us to use. So as you can see, I did my little comments and I created a list really fast. As I told you before, Python comes with some built-in functions. One is sum. So if I print my list, save it and run it, you can see it will give you the sum of all the numbers in that list. So sum is a built-in function. It's ready to go. You don't have to import anything to use it, but there are a great deal many other functions in the Python standard library. And if you go to this page, the document page for the standard library, you can see this list down here. It will tell you all you need to know about the standard library modules. And if you import them, you can use them. It deals with things like networking and doing graphical user faces, user interfaces, and a whole bunch of things we can do. Development tools, software packaging and distribution. What else do we have? Unix things if you're running on a Unix system or Linux. So there are a great many things you can look for. Right now we are going to play around with, let me see if I can find it, the math functions. So I go to the mathematical functions. I'm going to import the math library and do some fun stuff with that. First thing, usually I import my libraries first. So I'm just going to type import math. It's that simple. So now, let's say I wanted the square root of a number. Let's say a is equal to, I type the library, dot, and then the function or method that I want to run. You can see idle will list all of the available. All right, now it's not doing it anymore. There we go. It took a while. And why doesn't it let me go down the list? I don't know. Come on, idle, help me out here. All right, well, I'm not going to wait for that. I'm going to say, give me the square root of 25. I think I know the answer to that. And I'm going to print a. So when I do that, shouldn't be asking me for that. It'll tell me 5. And it returns a float, as you can see. I can also use absolute value. I can also use ceiling. I can also use a great deal other functions that are there. I'm not limited to math. I can come in here and load the statistics library as well, so that I can say b equals statistics dot mean of my list, the list I created up there. And I can print b. And as you can see, it's 49.71. That's a lot of digits there afterwards, so I'm going to clean it up. And the way I'm going to clean it up is I'm going to say c equals math dot ceil b print c. Ceil stands for ceiling, and all that does is round up. So now when I run the program, I get 50 because that 0.71 rounded up to 50. If that had been 49.1, you would still get 50 because ceiling goes up to the next integer, just as the function floor goes down. So if I ran floor on this, let's do it. you can see it's 49 because it rounded down. Okay? So that gives you the ability to use other functions. Now you might be saying what functions, and you can see them all here in the documentation and see what they do and read how to use them, what their arguments are. You have the function name. Remember all the components of a function name, and then you have the arguments or the parameters, and then usually it'll tell you what the return value is. So it'll tell you what the function does and what the return value is. One other thing I want to mention real quick before we get going on our little homework project is from. You see how I have math dot square root 25 here? If I want, I can say from math import and then tell it exactly what I want. So I want square root and I want ceiling. And then from statistics import mean. Then I don't need to tell it to go to statistics or math, because that from statement up there will associate the functions with the proper library. So then all I have to do, didn't do it somewhere. Floor is not defined. Maybe because I didn't load it. That's a good error to get. You have to remember to load everything you use, because if you don't, we did a blanket import before, and as long as you tell it where to go, it'll go find it. But if we do a from, you have to list everything that you're going to use. But now we're back in business, and we don't need the math in front, and we don't need the statistics in front. Basically what this means is that we've loaded these function names into what's called our namespace, and the namespace is where we have our variables defined and our functions defined and all the things that are germane to our program that we're running right here. Namespaces they go a little bit beyond the scope of the things we're doing right now. We'll probably do some more things with them in 5 and 6, but I don't want to give you a bad answer. That's basically what's going on. So that's as easy and as simple as import is. You find what you want to use in the documentation in this library. You use the from import or just the import to import functions from the library, and then you use them in your program. So you're not going to have to write your own code for square root or the mean of a sample or ceiling or floor or anything like that. Many of the common functions that you're going to want to run on your data basically already exist. Okay? So that's the basics of importing a library and using things. We're going to get more next couple of units. We're going to get more into third-party libraries where we will load Matplotlib and do some graphs, and we may load Pygame and do some really quick graphics with gaming and stuff like that. But I'm going to get to that another time. Right now I think it's more important that you see this and then you see the next thing that we're going to do, which is basically going to be to create our own library. Okay, I want to create our own library in order to perform a task. What task are we going to do? The first thing I'm going to do, because I want to follow along a path that is similar to your homework assignment, is I think I'm going to go grab a bunch of random numbers. Now you can see this. This will be interesting. I will go to Google and I will type random number gen, and random.org is what I'm looking for. Checking my browser, huh? All right. Random.org. This is where I go, and if you ever become an instructor and want to create a big file of random numbers like I do, you come here. I go to numbers, I go to integers, and it will ask me. I will generate, let's say 500 is good. 500 integers, and boom, you can see it just generates 500 numbers for me. But I think I want some larger numbers. So I will say 10,000, between 1 and 10,000, and 4 or 5 columns is great. So generate the numbers. All right, look at that. 5 columns of randomly generated numbers anywhere between 1 and 10,000. So I'm going to put them in a file. So I am just going to copy and paste them. Copy, and I go to Notepad, and I paste. And look at that. I am there. I'm going to save this. Save as. Where do I want to put it? I will put it in my Google Drive where I keep all the stuff for class. Unit 3. I'll call it examples. And what do I want to call it? I'll call it rnums.txt. All right. So now we have a file of random numbers, 500 random numbers between 1 and 10,000. It's called rnums.txt. And we, thank you, random.org, can do what we want with it. So I think what I am going to do is I am going to write a program that examines all of the numbers in that file and determines whether those numbers are a palindrome or not. A palindrome, if you don't know, is something that reads the same way forwards as it does backwards. And Python gives us a really neat trick so that we can do this rather easily. But let us see what we can do. Okay, the first thing I'm going to do is I'm going to write my library. So let me say new. I'm going to come up here. Just because it's a library doesn't mean it should not be commented. It's just as important to let people know what you're doing because they can read your library just as well as a main program. Library for palindrome program. Good enough. Now, I want to define a function that will return true if the string that's given it is a palindrome. So let's say def. I'm going to call this isPal, and I am going to input a string. I'll just call it the string or the str. And then what I'm going to do is a little trick with slicing strings. What I'm going to say is if string, not string, the string is equal to the string, but I'm going to start at the beginning, go to the end, but when you slice, you can tell Python that you want to go backwards. So if you go back and look at the slicing stuff that we did a unit or two ago, you can see if you put a colon in there, you'll get the default. The default is the beginning. Do it again, you get the default for the ending, but slicing takes a third parameter if you desire, which tells it to go backwards. So I'm telling it, use the whole string, but go backwards. So basically what this conditional is doing is saying, hey, does the string frontways equal the string backwards? So if this is the case, I return true. And if it's not, I return false. I can do this because it is a binary choice. There's no third option. You are either a palindrome or you are not a palindrome. And we will see. I will test some stuff. Now, because I'm sure this is going to be a question that comes up with some assignment 2 stuff, I am going to create a variable. And I'm just going to call it Hodges. And I'm going to make it equal to 14. And then that's all I'm going to do. I'm going to set that variable. Now, unlike your other programs, that's it. We're done because we just want to define the function and we just want to define the variables. We don't want to do anything, and we're not going to run this. This is a library that's going to be used when we do our main program. So I'm just going to save this. And I'm going to say save as, and I'm going to save it in the same directory where I have my file. Hold on, let me show you all files so you can see. My file is there, my rnums. and I'm going to call it tools.py. So now I have a file, a module actually, called tools.py that resides in that directory. It defines a function called isPal, which takes a string as the argument and then tests to see if that string is a palindrome. If it is, that conditional there will be true. So it will return true. If it is not, it will return false. Then I come out and I define one variable. I'm calling it Hodges, and I'm making it equal to 14. Okay? Let's put that away for the time being. Now, let's grab our main program. New file. I will fill in the comments later. Right now, I want to start writing my program. First thing I'm going to do is I'm going to save it. And it's a shame I don't make you go all the way through this process every single time. Examples, I will just call this one main.py. Probably not the greatest name choice in the world because we often use main for a main function definition. But I am going to go with it. Okay. I'm at the very beginning. I want to read numbers from my file. I want to get them into a list because a list is a format where I can look at them and I can cajole them. And once I get them in that list, I'm going to iterate through that list and I'm going to use my isPal function to see if they're palindromes or not. So what do I want to do? First thing I'm going to do is I'm going to do my import. You know what? I'm not going to do my import. I'm going to do from. I'm going to do from tools, not tolls. I'm going to say import, and I will import isPal, comma, and Hodges. Okay, great. So I've imported my library. I've told it I want to use the isPal function and the constant Hodges. Now I want to open my file. So I'm going to say in file equals, what did I call it? rnums.text. So I'm just creating the string that has the file name in it. Then I'm just going to use F, forgive me. I'm going to open the file. Actually, it doesn't matter. I could use double quotes there if I wanted to. I could use single quotes too. Call that. Then I'm going to use F dot read. Oh, that was a big mistake. I'll call it data equals F dot read. Boom, boom. And then I don't need my file anymore because I've read my data in. So I'm going to be a good citizen and remember to close it right now. Let's put a little comment over that. Let's say open file, read data, close file. And technically that should be all we have to do as far as file input and output is concerned, because now, if I am not mistaken, we will have our data and we can print it out. Yeah, all right, look at that. So we've read all of our data in to the string, and it prints in the same format that we saved it in. And the reason it does that is because when it was created in 5 columns, it did number, tab, number, tab, number, tab until it got to the 5th number. And at the end of the 5th number, it did a new line. So think number, \t, number, \t, number, \t, all the way to the end. After the 5th one, it is \n to give you a new number. So don't think of these as the spaces. Think up a level and think \tab is there, \tab is there, \n is here, because we're going to use that. We're going to actually use that right now. So I have a string with my data in it, but it's not going to help me when I want to examine all the different numbers. So we're going to clean, or we can say prepare our data in order for us to use it. So what's the first thing we want to do? I want to create a list, and in this list I want to have all of the items be my numbers. So eventually I'm going to have to divide that up into just the numbers, and when I divide it up, I'm going to want to look for a certain thing that we call the delimiter to use as something that splits it. So when I go back and I look at that file, I'm thinking to myself, the natural thing to use is the tabs, because think about it, the numbers are separated by the tabs, but there's a problem. After that fifth number, there's a \n. There's not a tab there. So if I split by the tabs, I'll get number, 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 and then I'm going to get a new line and another number before I get a tab again. So there's going to be some problems there, but we're going to take care of those problems right now. We're going to say data equals data dot replace. And what I'm going to do is I'm going to replace all the \n's with \t's. Now think about that. What is that doing? That's going to take those new lines and make them tabs. So all of the numbers will be separated by tabs. Let's actually print. I'm curious what it's going to look like. All right. So now we've gotten rid of the new lines. The only reason we go to a new line here is because that's that's idle. Let me see if I can grab this. See how we spread out? There's just tabs there. If I could spread this window longer, it would stretch across the whole window because there's no new lines there. The only reason we're going down is because this shell window is a certain size. So now I have the numbers and they're separated just with a tab. And that's exactly what I want, because the next thing I'm going to do is this. I'm going to say data equals data dot split. And I need to give it the delimiter. And I'm going to say the delimiter is a tab. So now what does split do? Split takes the string data and separates all the items in it that are delimited by /tab or \t, which is the tab, and it's going to create a list called data. So now let's print data and see what we get. And there's our list, as you can see. I go up and you can see the bracket there, and now it creates strings, but they're strings of numbers that we need, and we can use casting and very easily get by that. So now we have numbers in a list. And we can even see how many we have. I'm guessing it's going to be 500, but can't hurt to double check. 500 is what I gave it, and that's exactly what it is, 500. So now I'm in pretty good shape because I've read in my file, and I now have a list of 500 numbers. Yeah, it's a string, but that's okay. Actually, in this case, it's really okay because I want to use the isPal function, and the isPal function takes a string, so I'm not going to have to do any casting at all. So now what do I want to do? I am going to iterate through the list and find the palindromes. Now, I never tested isPal. I should have, but we're going to test it right now. So, for I in data, if isPal I can just leave it there, but if that's true, then print it. All right, so I'm now iterating through my data, and when I grab an item, I say if the isPal function that we wrote, which returns true if the string is a palindrome, equals true. I don't need that extra space. Then I print I. So if it's not, I just don't print I. So when we go through the list, everything that we see should be a palindrome. I cannot imagine that we created 500 random numbers and one of them isn't a palindrome. Is there one I can even see? I can't see one with the naked eye. I'm good. I ain't that good. All right. Let's see what we had. Hey, look at that. All right. I'm guessing my palindrome function works pretty good because everything I'm looking at here is a palindrome, as you can see. 9229, same forwards as backwards. 66, watch out for the 666 now. That's not a good sign. There's 4 6s. 1001, 656. So that's pretty cool. I'm guessing that works. So we've gone through here and we found out what all our palindromes are. Now I'm going to do one more thing just to show you. I'm going to print Hodges. Now, as you can see, through this entire file, through the entire main program, I don't define Hodges. I read it in from our library, but I don't define it here. And because I'm only working in here, I can't really change it, which is why we call it a constant. There are constants in other languages that you actually define with a keyword constant, C-O-N-S-T. I know that exists in C, and if you put a gun to my head, it might exist in Java. But in Python, you don't really force constants. What you do is you define them in the library, and then when you use them, you can't change them because you're not really accessing the library. You're using your program and reading them in. So they're constants in name. If you use other languages in the future, when you use C++ or something like that, you might see the constant keyword. In Python, you don't have to worry about the constant keyword. And when you see me in an assignment say define a constant, all I want you to do is define the variable in the library and then read it in and use it. So when I print Hodges, it should print 14. Actually, what I'm going to do is I'm going to shoot myself a new line before I print it to make it readable. No, actually, Hodges is a number. So let me use a comma and not try to concatenate there. All right, fingers crossed. And look at that, 14. Okay? Oh, why did it give me the space? Oh, there's no way I can get it. Right, I get it. It's because of my comma. I guess if I wanted to, if I really wanted to be a nitpicker, I could do that. And that still doesn't get rid of my space. Really? Oh, because it's the end. I need to redefine the comma thing. Oh, well, forget about it for now. I'll live with it. Okay, so that is how that program works. It prints all of the palindromes in the list. And the list is big. You can see we printed it out here. Remember, I'm in the command window, so I can look at all my variables if I want. You can see, big long list, 500 numbers. But what I did was I iterated through it, and I used my function. And if my function returned true, I printed it. And what I printed at the end of the day was the palindromes. So think about a similar situation. You're going to read in a file of 5,000 numbers. You're going to prepare your data. Then you're going to iterate through your list using your harshed function is harshed. And when you go through that, you save it to a list. Then you'll have a list of all the harshed numbers. Once you have that, then you can run another function that you create and keep in your other library. Do I have the library up? Yes, I do. So I can show you the whole tool chain right here. So then you'll have a function called isHarshed, which will tell you if it's a harshed number or not. And then if it returns true, you can put that number in a list. Then you'll have a list of all the harsheds. Then you can run that list through another function, that the siete function, that allows you to see if there's a 7 in the second column. And when I say 7 in the second column, I mean like this number right here. See, there's a 7 in the 10 spot. That would be a number with a 7 in the second column. Is there any other one that jumps out at me? Like this one here too. 1076. There is a 7 in the tens column. That would count for the siete function as well. Okay? So after you do that, you're going to be able to create a list of harshed numbers that have a 7. So then after you do that, what do? Test for the multiples of 41. Now that I don't think you have to save to a file. All you have to save to the file is the harshed numbers that have a 7 in the second column. But this is what I'm talking about. We just did it in this little review video right here, so it's not a huge, super big deal. But this is the basics of modularity. So I've now created a library like, let's do it. Save. Goodbye, main. See you later, bye. Grab a new file. File, save as. And I will call this one another main. Maybe I'll just call it another.py. And I will import tools. And I will, let's say, for I in range 1 to 1000, if tools dot is pal, because I have to use the is tools in front because I just imported tools. I didn't say from tools import is pal. I have to tell it what to do. I'll be honest, I like this way of importing better because it's better to my mind to specifically tell Python in the code what library I'm using, because if I'm a programmer who's reading this code for the first time and I'm in the middle of the code and I just see a function name, I don't know if that function is handwritten, I don't know if that function comes from a library, I don't know where it comes from. But if I'm in the middle of a file and I read that, then I say, aha, I'm going to the tools module and I'm grabbing isPal. So if that equals true, then print I, not one I. I'm guessing I'm going to have a lot of 111, 333, 444s. Let's save it and let's run it and see if it works. Uh-oh, dun 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 dun. Dun, 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 dun. How about giving it a string? Give the people what they want. That's a good example there. isPal takes a string, and I was giving it a number because that's what range produces. And Python said, So I'm going to correct myself, and before I send I in there, I'm going to cast it to a string. I think I'm going to be all right now. And I am. And as you can see, from 1 to 1,000, there's a bunch. You get all the doubles. 101, 222, 232, 303, all down the line. As you can see, every one of these is a palindrome. So my function is working pretty well. And you can also see, because we use strings, A equals tools.isPal, race car. Guessing A is going to be true, and it is. So you can do palindromes all the day long. Okay, you can use strings and you can use numbers. Just make sure to cast them first. And now the whole reason I did this is to show you I didn't write the palindrome function again. Why? I had a library. It was sitting off to the side, and all I had to do was say import tools. So I had my library and my function ready for me. I don't have to write that ever again. It's just ready for me to go ahead and use by calling it after I import my library. So that supports code reuse, and it's a better way of doing things, and that's the whole idea of modularity. It's taking different tasks and separating it out and keeping them separate so you could play with the code or alter the code without having to worry about changing a whole bunch of different spots in a program or something like that. Just compartmentalize it, put it off to the side, do it well so you know how it works and that it'll work with all kinds of crazy cases. And then once you've done that, you have a library and you can use it. So that's why we separate things out, and that's what modularity is all about. Okay? All right. Then that is that. What do I need to tell you? 15 million things is what I need to tell you. Number one, I know we've got a pretty busy 7 days ahead of us because there's a lot of deadlines and there's a lot of things to think about. First thing we're going to think about is Tuesday, the midterm project, the online resource review is due. Do not forget, get it to me midnight Tuesday and all will be well. I realize 4 pages isn't the end of the world, so it shouldn't be that bad for you. It's 2 pages plus the magic of double spacing, so you should be all right on that. Looking forward to reading those too to see what you think about that. Number two, Eric and I spoke together during the week and decided, you know what, we're going to wait until the midterm project is finished before we start hitting you with stuff for the big final project. We want to give you more time to let you concentrate on these things, because we realize the other things that I was going to mention. Next Thursday, I believe, is the 22nd. That's the day the assignments are due. So, but as we just did in 15 minutes, blah, 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 you can get it all coded up, so it shouldn't be a hassle. But it's going to take some time, and it's going to take, some work to get everything straightened out and make sure things are running. So I want to give you time for that. Next Thursday is going to be a quiz, but again, it's not going to be a crazy one. But I want you to put aside some time for it and consider everything. And then, no, actually Thursday is going to be the quiz, and then Friday the assignments will be due. So that's a lot of stuff, and I want to make sure you have time to see this video, which is why I did it tonight. And I didn't want to wait any longer, because I want you to have the weekend in order to see this and use it. What is something else that I want to mention to you? Number 3, please go to the Sakai polling section and answer those questions for Dr. Silver, because she's trying to set things up so that it's the most convenient for you and that it works for you as students. So answer those questions and let her know what you're thinking so she can make plans, because I know it seems like the semester just started, and it did just start. I mean, it's only 6 weeks old, but already plans are being made for the spring, and she needs that information for you guys. So if you can, go to the poll section in Sakai and answer those questions. Yet another thing, I know it feels like I'm piling on, is to go give me a small paragraph in the section about the algorithm TED Talk from Slavin. Because I've always found it a really interesting talk, and I recently, 6 months ago, read Flash Boys, and it's just a fascinating topic, and it really ties in with data science in a couple of different ways. I haven't done it yet, but I've got a pretty good data science book recommendation coming your way. I've got something coming from Amazon, and it looks pretty swift, so I'm going to get that to you. I recently put an article up in the data science resource folder, so go in there and take a look. And things should be cool there. All right? I know this is a lot of stuff. Oh, I'm having a hard time saying it. So keep going. Keep doing what you're doing. People are asking me some questions, and they're really good questions. Another thing I should mention, if you have a question, put it in the forums. You don't have to send me an email. I'm more than happy to answer your emails. And if you want to send me an email, please do so. But if you're asking a question about the code or about the assignments or something like that, I know Charlie sent me a bunch of good questions. Peng sent me some good questions. And I told them both, you know what? Put it on the forum, because that way when I answer the question, everybody in the class can see it. And we can get some conversation going and collaboration, and everybody can work together to answer some questions. And I'll monitor it, so don't worry about someone saying something kooky and it not being corrected. I'll read everything and I'll monitor everything. So you have no problems there. All right? Talk to each other. Ask each other questions. Everything's going to be good. Okay? All right. Then I am out of here. As you know, the Mets won the National League Division Series and are now in the championship series versus the Cubs. Tomorrow night is game 1. The Chicago Cubs are coming to Citi Field to play the Mets tomorrow night, and hopefully the Mets will beat them. I know everyone's going to root for the Cubs because they haven't won a World Series in a bazillion years, but I'm not. I hope they lose. All right? So I'll be in touch over the weekend. I'm sure something will pop into my head. And at some point over the weekend, I am going to do that rainfall problem video and get it to you, because I think it's interesting and you might get a kick out of it. And I'll throw you the paper that started all the fun and all of that stuff too. All right. So keep coding. Do a little bit every night. This is fun. Remember that. All right. You have a good night. And then I'm going to get out of here. Hopefully that will be an easy process. Ouch. This video went long. 40 minutes. Oh well. Hopefully it's helpful with the program. All right. I'll talk to you later. Bye.